That was like the one miracle art project.
Refer back to, but you don't have to. And as you guys get older and older and move towards this whole college thing, one of the things that the transition that you're going to have to make, not just in math classes, but other other classes that you take, don't blindly just write everything down. If you know it already, you don't have to write it down, right? So if I get up here and I say, okay, so today we're going to work on equations of lines, and I go y equals mx plus b, and say m is the slope and b is the y-intercept, you don't have to write that down because you know it already, okay? So sort of be a thoughtful consumer. Write down something, yeah. Okay? There's going to be some stuff that you're not going to understand. Okay, so we're going to tackle the tangent problem that we talked about yesterday, the slope of the line, slope of a curve, in more detail today. I'm not sure how far we'll get, we'll just find out. Okay, so if you look at, well, let's see if I can do something fancy here. Here is the idea behind what we're working towards, I hope. Okay, somebody give me a function. Okay, give me a nonlinear function, I should have said, because those are too easy. So you can find the slope of y equals x really easily, right? What's that?
1 over 1.
1 over 1, yeah, 1. Okay, so give me a nonlinear function.
X squared.
X squared. Okay. No big deal. All right, so let's take a look at the graph of x squared, which is that guy right there, right? And then what we're going to do, like I said yesterday, I'm not sure if this is going to work or not. I'm trying to select that. Nope, it's not going to work. Shoot. Okay, I wanted to put a point. Oh yeah, point on point. Okay, so there's a point on this graph right there. See it? Okay. What we're going to try and do is we're going to try and find the slope of the curve at that point. Does that make sense? And here's how we're going to do it. We are going to take another point on the curve, say this one right here, and I'm just showing off for my student teacher here, just so you guys know it's totally extra, but you know. And let's take a line that goes through those 2 points, okay? Is this the slope of the curve at that at this point right here? No, it's a slope in between these 2 points, right? But as we did in the problems at the beginning of class, all we know how to do is to find the slope between 2 points, correct? Okay, so how can I change this point right here to make it so that this line more closely represents what you would think of as being the slope of the curve at this particular point? Okay, good. Let's take this point and move it closer. Okay, so if I move it closer to that point right there, could you see how the line was changing? Okay, so it's kind of like the rectangles yesterday. We talked about using more or fewer rectangles. As I get closer to that point right there, is this at least a better representation of what you would think of as the slope at that point right there than the other one? Okay, how can we get an even better representation of it? Let's move it even closer. Okay, so now you can see that that line is changing but not as much. Okay, so that's a pretty good representation of it, right? Can I get closer? I probably could. All right, let's try and get closer. Okay, and then let's see what this software, I was hoping the line would disappear when they got right on top of each other. So at some point, this point right here is going to be right on top of that other point so that they're the same point, right? Would I then be able to use our, slope y2 minus y1 over x2 minus x1 form to figure out the slope if the 2 points are right on top of each other? No, okay? So do you understand that there is a, wait for it, limit to how close those 2 points can be, right? Okay, so at some point you have to stop because they're going to be right on top of each other. So what we're figuring out when we're figuring out the slope of a curve at a particular point is not actually the slope at that point, but we're going to take closer and closer and closer and closer and closer looks. And then we're going to sort of see a little pattern, and we're going to say, okay, well, if we keep going, then I'm guessing that we're going to end up at this particular number. Even though we're never going to get that number as the answer, that number is what we're going to talk about as the limit, and that number is what we're going to use for that slope. Does that kind of make sense? Just nod your head. You know. Okay, yeah. Oh yeah, good. That's even better. Give me a little verbal dealio. Okay. You guys, I see some of you have some calculators out. If you have a calculator with you, go ahead and get that out, would you? All right. So let's do what? Okay, there's one on my desk.
Please excuse the interruption. If there are any 7th or 8th graders who have not had their picture taken, please go get them taken right now. 7th and 8th grade.
Yeah, I knew that. Second drawer there.
Most of them are
Yeah,
look at that.
no, they just need new batteries. Okay, so let's take a look at this curve, y equals x squared, the one that we were just talking about. And let's find the slope of the thing at the point 1, comma 1. Okay? Is that point on the graph, first of all? How do you know? Because 1 squared equals 1, right? Okay, so in this case right now, our x1 is 1, and our y1 is also 1. So what we're going to do, and I need to warn you, you got to sort of stay with me for a little while. There's a number of times in this class where we have to do a bunch of work to figure stuff out, and then later on I'm going to give you like the easy way to do it, and then you guys will want to like beat me up after school, but you can't. Like church, you know. You can't. There's not enough of you in here. Just use that. So we're going to do this to sort of like work on that concept so you understand, you know, exactly what I was talking about, but then we're not going to do this all year, what we're about to do, okay? All right, so somebody pick an x value for me relatively close to 1. Let's not get too crazy, let's not get too close. Okay, just kind of close to 1. 5. So let's take another x value as being 5. Okay, if my x is 5, what's my new y? 25, because 5 squared is 25. Okay, so first, just to pause here, you guys understand where these y values are coming from? Yes? Okay. Yell at me if you don't know what's going on. You guys are being awfully quiet. It's scaring me a little bit. All right, what is the slope between those 2 points? What? 20? What's the change in the y values? What's the change in the y values?
25. Well, no,
What's the
24.
change in the y values? 24. What's the change in the x values? 4. 24 divided by 4 is 6. Okay, so there's our first guess. And that would be like on this graph here. That is not a very good guess because those points that we chose, in fact, if I move this to 1, 1, I can move this to 5. Well, I can't quite get to 5 because it's off the graph. But that's not a very good guess because these 2 points are not very close together. Okay, that's a starting point, and we need a starting point. Got to start somewhere. All right, so let's try again. Let's do x1, y1 are both 1. Sorry, Matthew, if you're watching this at home, that is a y. Now you're going to choose 2. Okay, what's my y value if x is 2 and my equation is y equals x squared? 4. Okay, this is where the calculators start to come in. Well, not yet, I guess. What's the slope? 3. Okay. So we have now moved this. Too bad Mr. Pugh and Mr. Winter are in here now. I'm going to got this. Let's go down and make him watch it. So so now we're moving this point a little bit closer. So we were at 3, okay? So now my tangent line or my secant line looks like that. All right, let's keep going. So x1 and y1 still stay the same. Now we want to get closer. How can you get closer than 2? Impossible. Oh yeah, decimals. Okay, so let's go 1.5. 1.5 squared is, you know this. You forgot it?
2.25.
What? 2.25.
I remember how I did it.
All right. So there's a 5s thing that you can, it's really easy to do. Okay, so what's the slope? You can use your calculators, it's okay. Change in the y's is going to be 1.25. The change in the x's is 0.5. 0.25 goes into 1.25 how many times? What did you come up with? 2.5? Okay. So do you see a pattern here emerging a little bit? 6, 3, 2.5. So those numbers are getting smaller. All right. Any guesses right now? Early guesses? What our answer is going to be? Anybody want to take a stab? No? All right. Let's keep going. X1 is 1, Y1 is 1, X2 is, let's get closer. Nice. 1.25. And 1.25 squared is, you got those. 1.5625. All right, so we can figure out the slope there. The change is, the y's is 0.5625. The change in the x is 0.25. And if you divide those two, you get 2.25. Okay, so when we went from 5 to 2, we had a big jump from 6 to 3. Now the jumps are getting a little bit smaller. Can you see that as we get closer and closer together? Let's play one more time. Give me another x, close to 1, closer to 1 than the other. 1 point what?
1.1.
I heard 1.01. Let's get crazy. It's time. 1.01. All right. Whoops, that's x2. 1.01. So 1.01 squared is 1 point, a lot of zeros and then another 1. 0.0201, right? Okay, so the slope is 0.0201 divided by 0.01, which is 2.01, right? Okay. So, any guesses? 2. Okay. Right. And so what we're doing here is we're sort of estimating because these are getting closer and closer and closer to. Yeah, you guys can go. Watch it at home. Okay. You'll have to kind of fast forward through what you already saw. But, anyway, so as we are getting closer and closer and closer to 1 with our x values, these numbers are getting closer and closer and closer to 2. And if we wanted to get really crazy, because you have calculators and we could do it, let's go 1.0001. What's 1.0001 squared? 1. Okay. And so if you figure out that slope, y2 minus y1 divided by x2 minus x1, you're going to get 2.0001 for that. Okay? So we're getting closer and closer and closer all the time. Okay? In fact, this isn't a big part of this course, but you might talk about this in college. We could decide how close we wanted to get, and we could pick a point and make that work. So if you said, I want to come up with an answer that's 2.12 zeros and then a 1, then we could find a point that would fit that, and it would work out. Okay. I don't know that you're going to get this, but I'm going to ask this anyway. What's been true about every one of these x values that we have chosen relative to our original one? notice that they're all bigger than it, right? So I said we had to get really close to 1. Is there any reason why we wouldn't get close to 1 but be on the other side of 1? You know what I'm saying? Like, can you name me a number really close to 1 that's less than 1? 0.9 or something like that? Okay, and we'll talk about this more later in this course, but it's important that you check both sides of the number. Y equals x squared is a really pretty simple graph with nothing weird going on in it, but if we we're looking at some other ones, for example, if we were looking at 1 over x, because there's this big break in here, funny things happen, okay? And that's going to become important later on. Y equals x squared is simple, but just for funsies, to make sure that it really does work, let's check a number really close to 1 but less than 1. So just 0.9? 0.99, is that good enough for you? 0.99. Okay, so if we choose 0.99, then 0.99 squared is 0.9801. And then if we figure out the slope between those 2 points, you'll notice something a little bit different happens, but it still is okay. What does that come out to be? 0.0198 or something? When you subtract the y's. Oh, really? I wasn't close? Oh, for the... Did you figure out the whole slope or just subtract the y?
Yeah, the whole slope.
Okay, so the whole slope came out to be what?
0.199.
No, I don't like that. I don't like that because it's not close to 2 and it should be close to 2.
Negative.
What did you get? 1.99. So you did something funny there, Zach. Okay, so you get 1.99. Is that close to our other answers? And can you see that since we're approaching it now from the other side, we're approaching the answer from the other side also? Okay, and so what we figured out then, the slope of the curve, I'm going to read it right. So through all that work, we came up with the slope of the curve at 1, 1 is 2. Because that's what all those values got closer and closer to, all right? All right, so what do we have now? 1 minute. So if you're ready to do yeah, you are ready to do a few problems. So let's practice this a little bit. And like I said, this is going to be a little bit tedious because you're just going to be plugging a lot of numbers into your calculator and recalculating slopes and whatnot. But we'll get past this fairly quickly. Okay, so I'm just going to give you a couple. And don't worry, they each only have a part A, B, C, D, E, F. Let's try 3. 4. 3 through 6. Okay?
Oh, yeah. Yeah, that's all bad. Nobody can actually play that. Yeah, he was in.
Okay, so before you guys leave me to go to football land, let me explain to you, let me translate the very first problem, and so you can see how it is exactly what we just did. I'm going to translate the math book lingo into what we were just talking about. Okay, so the very first problem says the point P, 1, 1/2 lies on the curve y equals x over 1 plus x. So what they're saying is, here's the function, y equals x over 1 plus x. What was the function that we used in the problem we were doing together? X squared, okay? And then they're saying x1 is 1, and y1 is 1/2, okay? And so throughout this whole problem, those two values won't change. Okay? Then for part 1, they say use x equals 0.5. So they picked a number fairly close to 1. They did not tell us what y2 is. How are we supposed to figure that out? Plug it into this equation right here. So you're going to have to take the 0.5 and go 0.5 divided by 1.5 is 0.3 repeating. And then you go y2 minus y1 divided by x2 over x1, and that's the slope. And then you keep doing that for all the different points. And then just like we did together, they're going to get closer and closer and closer to a number. And part B says using the results, guess the value of the slope of the tangent line, you know, da 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 da. Okay? So you're good? All right.